Hello, welcome to ATC Loudspeakers. My name's Ben Lilly, Technical Sales Manager, and we're here at the ATC factory for a tour of the facilities with the team from Soundstage in Cockfosters, London. We're going to start with voice coil winding, which is where all of our loudspeakers start their life. Welcome to the voice coil winding room. All of the loudspeakers we produce here start their life in this room. First select pure copper wire, high temperature enamelled for high reliability at high power levels. We exclusively wind ribbon voice coils, so flat ribbon profile voice coil drive units. So we have to take our round wire and flatten it down on this machine. So the round wire is loaded into this end, comes into this side of the machine, two hardened steel rollers. We're going to adjust the clearance between them using the vernier scale adjustment on the top. And then our ribbon voice coil wire is spooled on this following side. And we exclusively use a ribbon voice coil because it means we can pack more copper into the gap, approximately 30% more copper than a comparative length round wire coil. And this gives us greater efficiency. It also means that a heat loss out of the coil is maximised. We then take our voice coil wire, load it into the tensioning system here, and it comes onto the winding heads. So we wind onto either aluminium or Kapton voice coil wire using high temperature phenolic adhesive. And there's a voice coil nearly complete here. We wind slightly oversized, and then the finished voice coils are cleaned before going on to QC outside. Okay, so once the coils are wound, they're slightly tacky enough to hold them together. Coils are wound slightly too large, so they have to come out to QC here, where they're sized down in terms of their physical length and also for electrical characteristic. All the coils we make are edge wound using a ribbon voice coil, so this gives us approximately 30% more copper in the gap over a round wire coil, driving up efficiency. Once the coils are sized, they have to be baked, which permanently sets the adhesive used in the voice coil winding. Finished coils are then ready for the next stage of processing, where they come together with a suspension, cone and other diaphragm components. So next stage, voice coils come together with diaphragm components. Here they're being jigged with a cone and start to form something closer resembling a loudspeaker assembly. So step by step, the rest of the components used in the loudspeaker assembly come together. Moving on from where we were before with just the voice coil and cone, here we can see the spiders being attached and the rubber surround. So the steel cores have now been ejected from the voice coil assembly, and these are only a couple stages now away from coming together with the motor assemblies and taking the form of a finished loudspeaker drive unit. So we've looked at the assembly of the loudspeaker software that we refer to. Now we come to this area where we work on the hardware. These are the components that make up the magnetic assembly. Parts such as the backplate pole, shown here, the magnet, and front plate. So our motor assemblies are unmagnetised when we assemble them for ease of assembly, but also for efficiency. Magnetising a complete assembly gives us a slightly higher efficiency than magnetising individual components. So the components are bolted together, and then they're inserted, bolted together, bonded together, and then magnetised. So the magnetiser is a very high power supply with a specifically designed coil that creates a focused magnetic field in the centre. This aligns all the north and south poles in our assembly, magnetising the part. So this is our famous soft dome 3-inch mid-range. Forms a mainstay of all of our three-way systems, from the compact floor standard like the SCM40 all the way up to the biggest SCM300 main monitor. It's got a unique set of characteristics, very broad frequency range, high power handling. and a very neutral characteristic, and was designed really off the back of our managing director Billy Woodman's one, love of piano, and two, his realisation when the company was founded in '74 that the mid-range for Billy it was a key focus if he was to build a loudspeaker that really stood out from the pack. Our ears are most sensitive in the mid-range, and it's where a lot of emotion, it's where we communicate, and as a result we're extremely sensitive to it. So the performance of all of our loudspeakers in the mid-range is key, and we never compromise performance in the mid-range, the balance of the speaker over its performance, the frequency extremes. And the 3-inch mid-range dome is really key to that. And is loved by people worldwide, be it in the world of professional audio or in the world of hi-fi. So we've progressed from the bass driver and mid-range production, and now we're in the tweeter production room where we assemble all our tweeters. Two versions, one used in the mid-level products and the S version as used in the high-level products. This is my colleague Richard Newman, who's going to tell you a little more about it.
Okay, yeah, for a long time we've made bass drivers and mid-range dome drivers. Over the last probably 7-10 years, I think, we've been working on tweeters, and for the last 5 years we've been installing our own tweeter in our own products, and now just about every model that we produce has an ATC tweeter in it. The design of the tweeter is quite unique in the marketplace in that it takes a lot of cues from our mid-range dome. The idea initially was to try and scale down the mid-range dome into a 25mm device, and that's what we've done to the best of our ability really. It's a little 25mm tweeter on a mounting ring, just like the mid-range dome, loaded into a very, very high-powered neodymium magnet assembly.
What power level did you get out of the motor assembly on the tweeter, Rich?
On the S version tweeter, it's got 2 Tesla in the gap, which is a really high flux density. That high flux density keeps the third harmonic distortion particularly low, the efficiency of the device high, and the bandwidth of the device high too, so it has a very extended top-end response. And
the goal's always trying to ensure that our loudspeakers convey as accurately as possible the original material, the original recorded material that's been sent to them. We're always trying to produce systems that are capable of neutral fidelity and really high dynamic range. So all of these engineering methods and techniques and features of all these products, they're all there with the end goal of delivering a product that's as truthful as possible to the original recorded material.
Yeah. And with the tweeter, we tried to develop a device that was suitable for partnering with the mid-range dome, the infamous ATC mid-range dome, and we feel like we've finally got that part.
Yeah, the thinking was that if we could apply materials and engineering that had been successful on the dome to a tweeter, not only would we come out with a part that would perform very well, but it would also marry up very well with the rest of the system. So, and if you go all the way back to the beginning, having our own tweeter just meant that we could have our own philosophy across all the components used in the system. So we could ensure not only best possible performance, but best consistency across the range as well. Okay, so now we're in the drive unit testing room. As you can hear, we've got a drive unit hooked up to power amplifier here for QC. So all of our drive units, all of our bass drivers undergo, and mid-range drivers undergo a very rigorous QC test once assembly is complete. So we test at a QC test at a minimum voltage level of 20 volts. This is quite stressful for the drive unit, but it ensures we eke out any problems in the driver before they go into a finished system and leave the factory. So here Toby is long-term testing this bass driver from SCM40. So at 25 volts, so it's got an extended period of test, thermal test initially, and then he'll sweep through its operating range to listen for any rub and buzz defects, glue joint defects or the like. We can also listen out for any loose particles in the gap, any buzzing type distortions, any badly made glue joints, loose windings of the voice coil. And it does look like quite an extreme test, but applying rigorous test here means we get much lower defects in the field. As well as the manual test station we just looked at, we've also got an automated test station based around a Clipple QC analyzer. So we've got a test chamber here, test microphone inside, and this allows us to characterize all of our mid-range drive units very quickly and very repeatable, in a very repeatable fashion. Without actually listening to them. The mid-range defects are harder to hear, and because the parts are much more efficient and our hearing's more sensitive in the mid-range, it's not something that we want to complete manually. So Rich is going to load up a mid and we'll complete the test procedure.
Load it in, then we clamp it down to ensure that it doesn't move anywhere and there's no air gaps around that. Connect it up to the system. Enter in a serial number so we keep record of the drive unit. Press enter. So a series of tests are carried out. We measure the electrical response of the drive unit. We also measure the acoustic response and look for any distortion that might be present in the drive unit. And as you can see, this one's got a nice clean response. It would pass.
Like our loudspeaker drive units, all of our electronics is built in-house, be it standalone electronics, preamplifiers, power amplifiers or source, but also our active amp packs. So since the late 80s we've been strong proponents of active loudspeakers, and that's a loudspeaker having its signal processing and amplification all dedicated to the loudspeaker and housed in the loudspeaker cabinet. Active loudspeakers have the distinct advantage of giving greater control over the signal than a passive network. With a passive crossover, you often make a compromise. You're trying to, during the design process, we're trying to optimize impedance, phase, and magnitude, and these three parameters are all tied together. So when you're modifying one to achieve greater performance in that area, you're often compromising the other two. By going to an active system implementation, we can have better control over the time relationship of the signal and the frequency and level relationship of the signal. We also have a dedicated amplifier channel for each band. So if we look here, we have a passive three-way network whereby the frequency dividing network occurs after the power amplifiers. Here we have the active amplifier with its active crossover network splitting into 3 bands and then having a dedicated amplifier channel per drive unit. This results in greater control over the bass, greater efficiency and better control of the timing aspect. And the end result is a more honest, more neutral, more musical result. In this area we have finished system assembly, so the drive units from the other building we saw earlier come together with the electronics from next door. Systems are assembled with their cabinets, and then we have final test whereby we ensure that all the electronics or passive crossover and drive units are all working together correctly to give us the exact right loudspeaker performance we're looking for. Okay, so final stage of the production process is system QC. So we've got a loudspeaker cabinet with passive crossover in it in this case. And we've got a QC system manufactured by a German company called Clipple. They specialise in loudspeaker test and measurement. And we've got our test microphone. So we're going to send a frequency sweep from 20 Hz to 20 kHz through the loudspeaker that's going to characterise the impedance and the frequency response of the loudspeaker and compare it to a golden reference, a system of known quantity that we standardised on at the start of the life cycle of the SCM11. So Richard's going to run the test sweep now. And now the power test. So the product's passed QC, it can be now matched up with its pair and packed before shipping to the end customer. Thanks Thanks to Dean and the team at Soundstage and Cockfosters for coming down for the day. I hope you enjoyed the tour around our factory and it's given you an insight into our products, our technology and our people. And thanks very much for watching.